In this demo, we are looking to build fault tolerance into our servers. There are three goals that we are trying to achieve. 1, clients should not be able to take down the server under any circumstances. 2, we should use the four-way closing handshake whenever possible using socket.end. So a four-way closing handshake is considered a graceful exit. And 3, when we notice we have lost a connection, we will use socket.destroy to terminate the remaining socket half. We have added a new connections array. We may have different sockets communicating with each other, for example, inside of a chat application. And so we will need to store each of those sockets somewhere. If those sockets need to be disconnected, we need to remove them from that array. Over here, we create our server using net.createServer, and then we attach a listener for the connection event. So when a client connects, we will call connect handler. So over here, we can see that we are given a socket object, and this socket object reflects the client who has connected to us, how we can communicate with them. So in the third example, we'll be looking at the socket.write method to send data. But for now, we are going to add that socket to our connections array, and then we're going to attach 2 listeners to it. So the first listener is going to be on the event error. This is emitted if the socket disconnects for some reason. End is when we receive a TCP fin from the client. So this is the graceful termination. So ideally, we would typically always want this to occur. We want to see the client disconnected message. If the error occurs, we are going to log the error. So we're going to use fs.append file to some error log with the current date and time, followed by the error information. We'll print a message to console. And then we are going to remove the connection using the splice method. We are going to use the socket.destroy to destroy our half of the communications. And so we can't use socket.end over here because at this point, this error will only trigger if we no longer have a connection with the client socket. If we receive a more sort of graceful exits, we will use console.log to disconnect it. We'll use connection.splice to remove it from our array. And then because this was a graceful exit, our application will send the fin message back. Because we have this error handler, this will no longer take down our server when a client errors out. So if a client crashes or something mid-connection, all we'll get is a message client has lost connection. Let's look on the client side. So we have a connection handler, which will establish our connection. And so on the client side, we have a socket. So the socket is also listening on the error. The first error that we're going to look at is the connection refused. So this will typically occur if you're trying to connect to a server that is not online. Okay, so maybe you did not start the server program yet. And so that's a very common issue. So we can just print a message and then just close the program, as we need the server to be online in order to communicate with it. And so there are other error messages, but for the most part, we're going to print out the error message and then just log it before terminating. So next, let's look at the end handler. Okay, so this occurs when the server sends a end message to the client. So we're going to print out receive the end, and then we're going to execute process.exit, which will terminate the program. And finally, we're going to look at the close emitter class. So the close emitter class, the overarching goal for it is that when the client exits their program, they can type in Control-C, and that will close the program. Or they can close the terminal by clicking on the red X to close the terminal. And Node.js provides us ways to detect when that occurs. And instead of sending a bunch of reset flags, we can do a four-way handshake right as that is occurring. So close emitter is going to be just a emitter class that will emit an event close when the person tries to close the program. And this is going to call a function terminate connection. And all it does is it will do socket.end, which sends a four-way closing handshake. And then once that four-way closing handshake is completed, it'll do process.exit to terminate. So let's look into this close emitter. Okay, so the only blocks that are going to be important to us are going to be these blocks over here. In Unix operating systems, Unix-based operating systems, when a Control-C is pressed, a SIGINT event is fired. And so we can detect this event, which will detect for a Control-C within terminal, and we will emit from our close emitter a close event. When there is a close via clicking the red X, a SIGUP event is emitted by the terminal, and we can listen for this as well, and we will also emit a close event on that. This additional block is here because Windows behaves differently. So the events on Windows are emitted from the readline library. Okay, so we have to sort of add in this additional code to deal with Windows. And the only difference is that if we receive a readline.onSIGINT, we're going to then emit a SIGINT, which will then cause this code to run, and vice versa for the SIGUP. Okay, so but otherwise it's essentially just an emitter for when someone tries to close the program. So we can also see that this is used on the server side. So over here we have our close emitter again. Okay, but the close emitter for the server side is more complicated. And the reason for that is on the client side, we only need to terminate one socket. On the server side, as we saw from the previous example, we can have multiple connections. We might have 4 or 5 connected clients that we have to disconnect. And so when the close emitter fires on the server side, we're going to call a function terminate all connections. And this function is going to keep track of how many sockets were closed, which is initialized to 0. If there are no clients, I'm just going to exit immediately. Okay. And if there are clients, however, then I'm going to loop through each of the connections. And for each connection, there's going to be a socket. And I'm going to call the function close socket on that specific connection. Okay, so if we look at this function, it takes in a socket and a callback, and it's going to call socket.end, which initiates the 4-way closing handshake. And then afterwards, it will call the callback. Okay, so we're going to pass in terminate after all close to this callback. So this gets passed into here, which gets passed into here, which gets called after each socket is actually closed. This function, terminate after all close, we'll increase the number of closed sockets by 1. And if the number of sockets that are closed is equal to the connections.length, then we can terminate the server. So essentially this is going to terminate the server only after all the clients have been closed via four-way handshake. So again, we have 4 terminal windows, 1 for the server and 3 for clients. Okay. And if we look in Wireshark, we can see that we have 3-way handshakes for each connection established. The ports used for the clients are 61619, 61620, and 61621, respectively. Now the client can disconnect by one of 2 ways. They can push Control C, which will close the program. And we can see over here that sent out the 4-way closing handshake, so we've gracefully closed. Our server has no longer completely crashed like prior, and our other connections are still established. I can in fact connect again, which will create another 3-way handshake. Okay, and now let's close this connection with just the close button instead. Okay, so that will terminate the connection on 61620. And again, that's gracefully because we have our 4-way closing handshake. And for our final example, let's see what happens when we close the server. If we close the server, then we can see that 2 pairs of closing handshakes originating from port 3000, which is our server's port, are sent out. The first one to this terminal and the second one to this terminal.